Welcome back, physics fans, and here we are with lesson 4 for work power energy chapter of physics 11, and we're going to be talking about heat energy to begin with. But let's just do a quick review here. Very quick, the first thing that we learned in this chapter, that work was force times distance. Even though force is a vector and distance is a vector, the answer is going to be a scalar, but we have to worry about the direction. As long as they're in the same direction, that is positive. If they're opposite directions, it's negative. The second lesson was on the work energy theorem, that work is the change in energy. We also learned on that lesson that potential energy, gravitational potential energy is mgh, and we have to determine where the h is being measured from. That's an important part. And kinetic energy is 1/2 mv squared. V is the speed, not the velocity. Direction doesn't matter. And then we talked about conservation of energy, that the total energy in a system remains constant. And then we focused a lot more on mechanical energy, and that was the potential energy and the kinetic energy, and is the total energy beforehand, and then the total energy after would have to equal that. So let's move on into, we've done a few lessons on those. Let's go on to today's lesson. Heat, like in the form of a hot cup of coffee, will always have a hot source to a cooler source, unless work is done, like as in your refrigerator, to cooling things down. Another note is that there is no such thing as cold. Cold object just has less heat in it than its surroundings. Heat energy is in the form of energy that transfers the particles in a system. Okay, by means of kinetic energy. That's the kinetic molecular theory, the particles bouncing around. In other words, under the kinetic theory, the heat is transferred by particles bouncing into each other. As a form of energy, the units of heat are in joules. Energy was in joules, as we've done before. Though heat is often and frequently measured in calories or kilocalories, and when a calorie is the amount of heat required to raise the temperature of 1 gram of water 14 degrees Fahrenheit, Celsius, 14.5 degrees Celsius to 15.5 degrees Celsius. Interesting definition of what a calorie is. We don't need to have that definition right now, or in Physics 11. Heat is also measured in other units like the British thermal unit, or BTUs. The heat power of my barbecue is rated in BTUs. Heat energy is often confused with temperature. Okay? For instance, if I have a bathtub of boiling water or I have a drop of boiling water, the temperatures are the same, but the amount of heat energy is different. The temperatures are the same. So heat energy is not the same as temperature. And to understand the difference, we use this formula in Physics 11, that we have the heat energy is equal to the mass of the object in kilograms, so that'll be in kilograms. C is another constant that depends on the material, just like mu depended on the materials in friction. C depends on the material that we're doing, and it's called specific heat capacity. Specific heat capacity is the name of that C, where mu was the coefficient of friction. This C is the specific heat capacity. And change in temperature. So T is the temperature, and the temperature is measured in Celsius. Okay, but it's not just the temperature, it's the change in temperature that's important. Okay, so temperature final minus temperature initial. The C's, the specific heat capacities of different materials, are right here. Water, 4,200. We'll be giving you these, or you'll have to calculate them. You won't need to have this table, but this is just here to help you with some of the questions down below. So different things take a different amount of heat. What does this 4,200 mean? It takes 4,200 joules of energy to raise water, 1 kilogram of water, by 1 degree Celsius. So taking a liter of water, it's about 1 kilogram, to raise it 1 degree Celsius takes 4,200 joules. If it was 1 kilogram of copper, it would only take 430 joules, which is about a tenth. So copper, you could change the temperature of copper a lot easier than you can change the temperature of water. Water is actually a great insulator. It takes a lot of energy to change its temperature. Let's start using it right away. How much heat does it take to raise the temperature of 100 grams of lead from 20 degrees Celsius to 33 degrees Celsius? Okay, so we're trying to find out the amount of heat. So that's the heat energy, and that equals mCt. So m will be 0.1 kilograms. The C, it's water. Nope, it's lead. So we look at lead and see that it's 130. Okay, and the units of it will be joules per kilogram per degree Celsius. I'll just put it in this time, but I probably won't often. Kilograms and degrees Celsius. And the temperature change here, we want the change in temperature, and that's going to be a positive 13 degrees. So it's going to be positive 13 degrees Celsius. So I'm just going to show you the units cancel out. The degrees Celsius cancels out with that. The kilograms cancel out with that. We'll end up with joules. And 0.1 times 130 is 13. And 13 times 13 is the 169 joules as the answer. And we get that. Okay? And that's about how you do the questions. So just try out questions 2 through 5 using this formula and finding out how many joules it takes to heat, or how much energy is lost, or the changes in temperature. Okay? And that's it. So let's try those and see if you can get those answers. Remember, smash that like button, subscribe, leave your comments below, and hit this and watch this often. Thanks.